All right, well, let's go. We're going to go through this tutorial. So if you want to follow along, you're welcome to. And I have a tutorial right here. I'm going to be just going through this. This is called Snowmelt Modeling in GSSHA. And we're just going to step through this and do it. Um, so if you look, you can read through the beginning. There's some overview stuff that Chuck's already talked about. And I'm going to start out by opening a file that's a part of this tutorial. And this file is called longtermsnow.prj. Right here. So this is just a GSSHA project. And it looks like the same basin we looked at, the Judy's branch. And one thing I guess you'll notice is there's all these coverages. These are just when you bring in a gauge or a project file in GSSHA, sometimes you'll have a lot of storm events with that project file, and WMS will read each of those storm events as a separate coverage. So it's probably best just to click this minus button to make those so they're not visible so you can see the important information here. And we open that file. You should see something like this on your screen. It should look similar. It may not look exactly the same. And then we're going to go to the job control. So to get to the job control, you're going to go to the 2D grid module. That's this icon right here. Go to GSSHA menu, and then you select job control. And the Snowmelt options are pretty easy to, so if you have it in WMS, if you have your project in WMS, it's pretty easy to set up Snowmelt. And it's even easy, if you want to do it outside of WMS. I mean, unless you're an experienced user, though, I'd recommend just using WMS. And to get to the Snowmelt options, you have to be sure you have a long-term simulation defined. And there's tutorials that show you how to do that. But we're going to click on the Snowmelt options, this edit parameter button here next to the Snowmelt options. So that'll just become enabled if you have long-term modeling turned on. And like Chuck said, it's going to run Snowmelt whether you want it to or not, because that's just the default in GSSHA. And so anyway, so you go to these parameters, and then we can enter this information, the dialog. So first of all, we're going to enter a hydraulic conductivity of the snowpack. And actually the default value that's in WMS is already there. And maybe we read that from the project file. I don't know, but that's already in there. And then we're going to define a dry adiabatic lapse rate. And this is the what Chuck talked about, where you define the temperature, how the temperature changes based on elevation. And so we're going to enter -5 degrees Celsius per kilometer, -5 for that value. And then the elevation of the HMET gauge is 140 meters. And then the base temperature to begin melt, we're going to enable this toggle box and change this value to 5 degrees Celsius. We're going to start melting when you hit 5 degrees Celsius. And the tutorial says just keep all the other parameters at the default values. Select OK to close this snow melt. And then in the job, so then we're going to go to the output control. That's this button here. Then we're going to select go here to the gridded data sets. And we're going to turn on the option to export the snow water equivalent gridded data set. So here's the gridded data sets here. Snow water equivalent is down here at the bottom. So we're going to turn that option on. And then we're going to close this output control. We're going to close the job control parameters. And it has a little write-up that I've kind of explained some of that stuff already. And then we're just going to go ahead and run it. So I'm going to run GSSHA. So you go to the GSSHA menu, make sure you're in the 2D grid module, go to GSSHA menu, select run GSSHA. And I should mention that another way to get to this is you can right click on your model here. This is the GSSHA model, it has a little M on the folder here, and you can select run GSSHA from there. It's the same thing, it does exactly the same thing. And then we're going to define a model name. So for my model name, I'm going to create a new folder here. We'll call it output or something. Or maybe we'll just call this solution. And I'm going to call this Snowmelt _ final. And then we're going to save that. And it's going to save the file before running by default. The only way to turn that off is if you turn off suppress screen printing, then you can turn that off. But normally you just want to save it every time you run. And then, because you might make changes or something, hit OK. It's going to start going. And so the thing you see that's a little bit different from what I was doing in my initial model here is that it has all this output. And this output is if you're doing a long-term simulation, GSSHA is going to give you this long-term simulation output. It's going to print that out. Even if you tell it to not print out any output, it's going to give it to you. So it's just telling us kind of where it is on the time. And I'm not sure how long this model runs. It probably runs for several days. We're going to wait for that to finish. And once that's done, we can go ahead and look at the results. So I'm going to wait for that to finish. And the results that we're going to look at are the snow water equivalent. We're going to look at that snow water equivalent data set after this finishes. So it has to kind of run through the winter, I guess. You see that this is the current date, so it's February. We have several precipitation events and the temperature changes through the winter to kind of model all that.
You can see how it's running through and getting the different events. Um, they'll sort of flash up when it starts a new event. That's all those events that Chris sort of hit at the very beginning here. Right? And you can see it goes pretty decently fast. You're not going to be waiting for hours, just a few minutes here. It's a pretty small watershed, so it goes pretty quick. You can actually turn all this off in the project file as well. There's a super quiet option. So if
Oh,
you're like calibrating, then you don't need all this, right? So you can turn it off. But
and we're into June by now. I think it stopped snowing at this point. I guess they want to make sure we get everything.
If you don't go into the summer, you don't get any runoff. So it's
Oh,
kind of
that's
boring.
you gotta wait
okay.
for it. Yeah. So PET is potential evapotranspiration, AET, actual evapotranspiration, infill is your infiltration rate, theta is your soil moisture, temperature of air, temperature of the land.
Temperature of air is that must be in Celsius, right? And
Yes.
the land is Kelvin.
It's Kelvin, yes.
I'm gonna do the whole water year here.
So one of the things about Geisha is that it'll actually switch time steps. Right? You don't see it here, but like when it pulls up a rainfall event, it'll switch into a very small time step, like seconds, right? And as you're so that way it'll infiltrate correctly, it'll get the runoff right, and move water through the stream at a very fine granular time step. And then when it figures out that like the event's over, it'll switch back to an hourly time step where it'll just do this, the evapotranspiration and work through the soil moisture routines. So that way you're not always constantly running at a very fine time step when you don't need to, when the processes that require a fine time step aren't doing anything.
Oh, we do have it going for the whole year. Okay.
Nice. Almost there.
Almost there. It's almost to the end of September. Once we get to September 30th, be done. You know, normally if I'm not doing a demo here, I'll just step away from my computer while it does this. All right, there we go.
There we go.
So
Yay.
it's going to read the solution. Take a minute to read the solution. So what we want to look at, after it reads this in, we told GSSHA to give us the snow water equivalent as one of the gridded solution files. So we're going to look at that snow water equivalent. And I mean, it also outputs the depth, the water depth and stuff, but we're focused on snow here, so we're going to look at the snow water equivalent after it reads this in. So here's that data set, snow water equivalent data set. One thing you can do is, let's go to the display options here. And we're going to select 2D grid data, make sure 2D grid data is selected. And then make sure your contours are turned on. We're going to go to the options here. Or actually, we'll just turn on contours, and then we're going to go click OK there, make sure contours are turned on. Then we're going to go to the snow water equivalent data set, right click on that and select contour options. And that brings up this contour options window. And in this window, we're going to set the contour options instead of normal linear. We're going to do color fill just because it looks nicer. You can fill in where the snow water equivalent values are instead of just showing contours of the values. And we're going to turn on this option to specify a range. And we're going to set the min to 0.01. And we're going to leave this value at the max. And we're going to turn off this option to fill below for the minimum value. So I don't want to fill below anything less than 0.01 meters of snow water equivalent. And then I'm going to go to the legend here. Turn on the legend. And we're going to make sure this display legend is turned on. I'm just going to change this title to snow water equivalent. Actually, if you just leave this legend title as it is, it'll have the snow water equivalent, which is the data set, and then it'll have it'll show the time step that I have selected. So let's just leave that as it is. And then we're going to select OK. Select OK here. And we're gonna just go through these snow water equivalents and click the down arrow on the keyboard. And eventually, maybe we need to page down actually, because there's a lot of time steps here. But eventually we're going to start seeing some snow. Okay, I'm going to go through here a little slower. So we start seeing some snow here. And the contours kind of change. Oops. So you can kind of see at the kind of beginning of the season, you get some snow water equivalent going away, coming back. It kind of changes like that and kind of page down through here. So in the winter, you got a lot of snow there until you get to February and into March. You can see that some of that snow water equivalent in the lower parts of the basin kind of melt. And then you get into April. May, still got some snow water equivalent. Then eventually it all goes away. I'm not sure if these are actually valid values or not, but I mean the temperature, I'm not sure if the temperature values are right for Illinois, but anyway, there we go. So that's kind of how it works. And then by the time you're into July, it gets warm and all the snow is gone. And that's it.
Can you show the hydrograph, Chris?
Oh, sure. You look at the hydrograph.
We get the annual hydrograph. That's kind of why Aaron and I changed this tutorial because it was so short that it didn't really show much. That's why we just made it a whole year.
That's the hydrograph right there, so you can see there. Goes from October.
It's a weird scale for a year, but
yeah. I mean, you could probably change
that's
that.
okay. But you can see how you get those little events in the early, and then you get the big runoff event kind of there, the big melt at the end of that's like May type time.
This one right here.
Yeah.
So
that like corresponds to what you were showing.
Let's see, how do I change the style? I don't know.
You're gonna ask us how you do WMS?
Yeah, there's some way to change some way to change the scale. I mean,
it's okay. It was just wanted to let them see that kind of how the flow corresponds to the suite.
This is October 2024. This is October. Is that date even right?
Oh, it probably doesn't match the actual data.
2024.
It might though. I don't know.
Yeah, I don't know what those tick marks are. Maybe those tick marks are months, maybe.
Could be.
Anyway. And I'll have to think about that, how to change that scale, but kind of hard to tell what date is what on there. That's the tutorial, though.
I got a question here. Does GSSHA produce hydrograph and water surface elevation at each grid cell?
It can if you ask for it. You can get a map of the depth, but you can get a hydrograph of the flow at each cell and also a depth at each cell, but you have to ask for the individual cells.
Yeah, it puts out the depth.
It'll put out a flow, but it has to be you have to ask for a particular cell because there's usually not a reason to get the flow at every cell.
you want the flow, you'd have to, I guess the way you do that in WMS is you define a node on that cell, and then you would double click on it. And no, maybe there's not a way to do the hydrograph at a specific cell in WMS.
There is.
If you
There
go to
is,
solution
but-
results right there, I think.
Oh, it's okay. Solution results. And then you get the,
So you turn on the display there. Like say the Snowmelt final geisha depth.
yeah, so that's the depth. That's the depth
So that's
plot
the
of
water
that
surface
cell.
depth. Yeah.
Now you have to
So the-
ask for the individual cells that you want the flows at, and whether or not you specify that in WS, I'm not sure. But
Is
there's a little,
that's
you
a
give the
card or
IJ
something.
you give the IJ location of the cell that you want the flow at, the cells.
Yeah, there is that option in GSSHA that you provide XY.
Yeah. Well, you give IJ location.
That's for
Maybe
the
it's-
overland,
It may
right?
not be in the, WMS. It's not something, typically what I've used it for is where there's a project where people want to know flows across a transect. And we pick the cells across the transect they wanted to see, and then that give them the flows across it. That's the only time I've ever used it. That's the only time anybody ever wanted it.
So the more useful thing would probably be to get the flow in the streams. You can get it anywhere in the streams if you just define this hydrograph output option for a stream node right here.
I mean, there are reasons to want to know the flow across parts of the land, but normally just across a particular region. And you can get that. But you can get a map of the depth at every cell.
Yeah. And Chris, if you do the select arc option,
Select arc.
yeah, and then pick the arc there, and then look at the attributes. Down to the very right, you see solution results there.
Okay.
And here's where you can look at different links and nodes along your arc itself and pull out these values for the solution as well.
Okay.
Great question. All right. Well, why don't we take a short break?